Hello again, and welcome to part 3 of 3 of today's 3 mini lessons. Today we started with definite integrals, and then we looked at fundamental theorem of calculus part 2, which really is just solving for definite integrals. Now we're going to end the lesson with the fundamental theorem of calculus part 1. I hope you watched those videos that I left for you, because I feel that video really explains well the difference between the fundamental theorem of calculus part 1 and part 2, and the examples shown give a great indication. So if you've watched those videos, this makes my job easier here today. I'll just do a quick definition. We'll do a few examples together. So the official definition, let's read it out together. We have it in our notes. If g is continuous on the closed interval ab, then the function g defined by g of x is equal to the integral of a to x, f of t dt, where a is less than or equal to x, less than or equal to b, is continuous on the closed interval ab and differentiable on the open interval ab, and g, the derivative of g prime x equals f of x. That is the fundamental theorem of calculus part 1. What does that mean? It just feels like a bunch of words and terms. So let's go to the next screen and we'll do 3 examples that hopefully explain what all those words mean. So again, if you watch that video, the fundamental theorem of calculus part 1 isn't hard at all. You're not really doing a lot, you're just kind of plugging things in. So it's quite simple. But the problem is that students get it mixed up. They get the fundamental theorem of calculus part 1 and part 2 mixed up. So it's not that it's hard, it just, if you apply the wrong method, then you're kind of done. So just make sure you're reading your question carefully and realizing, is it part 1 or part 2 that we're working with? So this one's easy. They say use the fundamental theorem of calculus part 1 to find the derivative of the functions. So again, if you watch that video, we're finding the derivative of an integral. So for fundamental theorem calculus part 2, we actually are integrating. You have to integrate, you use your antiderivative rules, you integrate, and then you replace the upper, lower limits and subtract the 2. But here we're not actually integrating at all. And it gets confusing, right? Because you see the integral sign, so you're thinking you're integrating, but we're actually finding the derivative. And if you watch that video, when you find the derivative of an integral, they cancel each other out, right? Because an integral is just the antiderivative, which is the opposite of the derivative. So derivative of an antiderivative is just back to where you started. So all that to say, these are easy. We don't really have to do much. So for our first example, g of x is equal to the integral of 0 to x secant squared t dt. Again, you're finding the derivative of an integral, so you don't need to do anything. It just stays the same. Secant squared stays as secant squared. All you have to do is replace the variable x with whatever variable you have. And again, that video did a really good job of explaining that. So we just change our t to x. And then the next thing you do is take the derivative of your term here. So the derivative of x is just 1. So that's why our final answer is just secant squared x. And again, if you watch the video, when you do fundamental theorem of calculus part 1, you can only have one variable. You need to have one constant and one variable. Your variable has to be the upper limit and your constant has to be the one on the bottom. So this is a really easy one. We already had the variable on top. We didn't have to do anything. So you literally just replace the t with an x and then get the derivative of what your variable is, and we're done. So not hard, as long as you're recognizing it's fundamental theorem of calculus part 1. We're not actually integrating, even though there's an integral sign. Okay, let's try another example. So again, we have g of x is equal to the integral of x to 1. Our limits are from x to 1, and our function is t over t plus 1 dt. Now again, the first thing you should notice, we have a constant, we have a variable, but they're in the wrong spot. So I have to change it. Can I just change it? Yeah, I can. My pen was kind of weird there. But you have to do a negative sign. So again, I did give you that sheet with all the integral rules. I think it's that pink sheet. Yeah, I have it right here. So these are the properties of the integral. So make sure you're following along, and they are in your textbook as well. So if you just make it negative, you can change it around, but this stays the same. Now we're ready. When you find the derivative of an integral, you don't have to do anything. All you have to do is replace all of the t's with x. So that's x, x. But don't forget, remember we pulled up that negative ahead in front. I'll just put it like that. It doesn't matter where you put it. You can put it in front. Just make sure that you've applied the x value. And then the last step is to find the derivative of x. The derivative of x is just 1, so we don't really need it. So I think that might be how I wrote it in your notes, but pretty straightforward. So just to watch out, make sure that your variable's on top and the constant on the bottom. one thing to watch out for. Okay, one last example. Again, just like if you watch the video, the last one they did I think was kind of complex, but again, don't be scared. It's really not that hard. So step number one, we've got an integral, 5 to 3x squared. We have a constant and we have a variable. Yep, so that works. The constant's on the bottom, the variable's on top, so that's good. We don't need to change it at all. And again, all you have to do to find the derivative of an antiderivative, you don't really need to do anything. We just are going to replace all of our t's with 3x squared. So wherever I see a t, the t becomes 3x squared. The t becomes 3x squared. That's literally all you do. And then don't forget at the end, whoops, that was supposed to be a bracket. The pen's even cutting out on me now. You do need to get the derivative of 3x squared. The derivative of 3x squared is just 6x. And we do not need to simplify. We're done. So there you go. That's the fundamental theorem of calculus part 1. So I know we have 3 topics today, but now you should be able to do definite integrals, which is fundamental theorem of calculus part 2, and fundamental theorem of calculus part 1. So you've got 3 short assignments to do today on these integrals. Good luck.